How's everybody doing? Welcome to hell. Or as I like to think of it, scaling Webpack to a lot of concurrent builds. How's everybody doing? Good morning. Everybody's awake, got enough coffee, had some breakfast, had a good time? All right. So, sort of a confusing talk title. You might just be wondering what's going on right now. But I'm Charlie. And I'm a senior director at GoDaddy. I run our UX platform team, so all of the cross-cutting user interface stuff, you can think of that as a pretty typical React control set that works in React Native, some shared headers, things like that. The canonical example I give to folks is if you use things like Google Docs and Gmail, you'll notice that there's a header that's sort of the same between every product. Most large companies have that problem, and it is a very challenging problem to solve. I'm also a board member of the Node.js Foundation. That's why I was late. Our board meeting ran long. And you can find me on the internet if you're interested in that. So what am I going to talk about? First of all, we're going to talk about this problem, which is scaling Webpack, which is its own sort of set of problems. Talk a little bit about Webpack itself and the challenges that it faces. I'm not going to go in too deep. This is more about techniques than, hey, this is exactly what you should put in your Webpack config. And then talk about how to structure a system like this. So we'll talk about things like starvation and queues and why those are important. And lastly, I'll show you a system that does this, that's open source, that you can go use if you feel like it. So let's talk about the problem. In particular, I like to think of it as a machine that makes ice cream. And that ice cream, of course, is Webpack. So it's Webpack as a service. How many people use Webpack here? How many people run Webpack builds on their own laptops and then publish the results to some place? How many people run Webpack in their CI pipeline, so like a Jenkins server or something like that? OK, so it's a fair amount. That tends to be the two solutions that people do. They either make something on their machine, right? So you run npm install, run Webpack build, take those assets and put them in a CDN or a file store somewhere, or you have the exact same thing run on a CI server. And this is going to be a little bit different. I'll ask one more probing question. How many people run just one Webpack build? Few. So everybody else, like, they do locale-specific builds, they do multiple builds for targeting, things like that, yes? OK. Yeah, and so you're starting to see the problem. So if you have to run 50 Webpack builds on your laptop, you are going to feel like this pretty quickly. And that's because Webpack has challenges, as any build system does. It's doing a lot of work. So let's talk a little bit about Webpack. So for those of you that don't know, it seems like everyone in this office does know, imagine your code is a car, and that's Webpack, right? And the output for each of these is a bunch of bundles. Of course, there's a lot more to that happening under the covers. You're walking required trees, you're building a module loader, you're replacing strings with numeric lookups in a table. But there are really some basics, and those basics inform how you would build a system that goes out and does Webpack for you at scale. The first of which is that there are a lot of files. Some of those files get written out, some of them don't. Figuring out which files are the good files is always a challenge because of the way that Webpack config works. Who uses the extract text plugin? About a third of the audience. If you're using the extract text plugin, you know that it's probably going to write a dummy file somewhere. So should you put that dummy file? What do you do with it? Pro tip for that is you should just make the file dev null, and then you don't write anything, so you don't get those dummy files. But of course, if you're doing this as a service, you can't tell people how to do things in their Webpack config. You have to sort all these permutations and handle them. The next one is just a ton of work. And your laptop sounds like it's taking off when you're doing a bunch of Webpack builds. You're using all 4 cores. It is just a non-trivial amount of CPU. And most of that is because of, well, first of all, it's reading a lot of files off disk, but there's also a lot of minification and source mapping going on, which is pretty CPU intensive. And all of this, when you deal with it day in, day out, you just end up feeling like this. At least I do. And that is because there is just config. Endless config. And I can't blame Webpack for the config, because it's really all of our fault. Because we all want this, right? Everyone. And then if you look like that when you see someone else's Webpack config, but it's because people want the Homer car. They do. They want all the features. They want to do JSON P loaders that request a module that just there are a lot of features. I'm not trying to throw shade on any particular feature, but there are a lot of them. And so if you deal with other people's Webpack config day in, day out, we can say that that is very clearly, oh man, this is just showing up great, hell. Hell is other people's Webpack config. Of course, now we're sort of off topic, so we'll get back to the problem. And that, of course, is Webpack as a service. The first thing you want to know is that it has to be reproducible, right? You need to have those punch cards get punched exactly the same every time. And so that's why I asked, do you run this on your machine, or do you run it on your CI server? And even if you're running on your CI server, you might not get the same level of reproducibility depending on, say, the local install cache that's on that particular CI minion where the build is running, and you'll get inconsistencies as a result of that. One of the really simple techniques to solve this is to change the way that you handle npm install. Stop thinking of it as I install and then I do something. It's install and store the tarball. Because once you have that tarball, that's the asset. That's beyond a package lock, beyond a shrink wrap. It's literally the result of that entire operation in a tarball forever. So you don't have to go back and trust that some new version of NPM is going to handle the shrink wrap the same way, or that it's going to handle the package lock the same way. You have the output. You have whatever bug was in NPM, that version of that day that you ran, or yarn, or whatever you're using. And when you can know that you have that tarball, the system in a naive sense becomes this. You have your code, you run npm install on a server somewhere, you store a tarball, something else fetches that tarball, runs Webpack, and stores the file somewhere. And you can happily start coding this, and you'll run into some very early questions, like, for example, what build output should you store? Which files matter? For example, if you're outputting both minified and unminified code, should you be outputting the minified code? Or do you want the unminified code? Because if there's a bug in the minified code, you still want the unminified assets, but how do you know which ones you actually want to serve to customers? And very early on, you'll see that this is the first of many, many challenges in this space. There's, I would say, 2 or 3 dozen small problems. Another one is, how do you send around your code? You're going to run npm install somewhere. How does it actually get the publish asset? And that's a simple answer. And if you've never looked at how the npm publish payload looks, I would strongly advise going and learning about that. We're not going to dive into it too deeply. At a high level, it actually sends your package JSON, and then there's a form delimiter, and then there's just a base 64 encoded tarball. If you feel like looking at this on your machine, you can install a little mock server, publish to it. It'll output everything it receives, sort of see it in real time. It's really useful if you've never dug through the npm wire protocol before. So now that we've got a couple of base things, let's think about some kind of naive solution. You're at your computer. You make a request to a web service. Let's call it npm install as a service. It eventually gets back to you and says, hey, I've stored a tarball. Then you're like, OK, great, there's a tarball. I know that that's there deterministically. So I can say, OK, let's go request Webpack from somewhere, from another server, and then that's going to store files. And the best laid plans, of course, end up looking like this, because it's not that simple. You wish it was that simple, but it's not. Of course, the reason for that is something that we know and love every day. I don't know about love, but we do use it every day. You make that request. You store that tarball. Request that Webpack. Goes out and stores that file. Now, those initial requests, they're both web services, right? And so what happens when you make, say, request for another build? DNS caching, right? So you could have 100 build servers, but you're going to get the same one until your TTL expires. And even then, there's no guarantee that you're going to get a good round robin in your DNS load balancing. So think about that. It works fine for maybe 1 or 2 requests, but at scale, this starts to get really frustrating. So everyone's computer, everyone that works at your company, depending on how big it is, let's say that it's relatively large and you have a couple hundred developers that might be trying to do this, they're going to go out and make those requests from this very large pool of servers. But if they're all getting DNS cached, they're going to end up with one machine. And you're going to end up feeling like this. Because you're going to have all these resources, and nothing's getting scheduled in the right servers, right? You have essentially what is referred to as starvation. So there's really simple, well-understood ways to work around this. If you've dealt with anything, we call them lines in America. I think here they call them queues. I don't know, queue up. So anyone used queues, AMQ, NSQ, those types of things? Good, OK. I don't see a lot of hands. Good. Relevant topic. So the thing about queues is that eventually there's some things you need to know. One of them is durability. So you have this essentially message broker that's living out there. But what happens when it falls over? What happens? Does it resend the message? Are those messages received in order, out of order? What other delivery guarantees do I get? So let's take a break, step back, and think about what are the characteristics of build systems. So let's not just go get AMQ because I heard AMQ was good, or 0MQ because I heard 0MQ is good. Let's think about what does a build system need from a message broker. Now this thing, it's going to go out. It's going to build the same thing over and over and over again. That means it's idempotent. So it can go out. You can say, look, build version 3.3.3 in prod, and you should be able to run that over and over again and get the same build output. If you're not, something is wrong, right? If there's some math.random in your Webpack config, I can't help you, right? If you run a build more than once and get different output, all bets are off. When you have that guarantee of an idempotent build, you know that order doesn't matter. So for example, at GoDaddy, we build locale builds. So if we support 42 locales, go out, language strings, things of that nature. I don't care if I build Chinese before English or English before Japanese or vice versa. It doesn't matter when this message broker gets me my message. I'll just do them. This leads to an overall characteristic that's called eventual consistency. So it can drop a message. I don't care. I'm just going to go reschedule it. Because we know eventually the state of the world is, hey, these are all the builds that should exist. Do they exist? Nope. That means we lost a message, so I'll just go reschedule those things. So there's a queue out there that does this really well called NSQ. It is non-durable by default. Messages can be received out of order. And lastly, oh, it's gone. So let's put this all together. There's obviously a bunch of characteristics here. This is where we get into the nuts and bolts of these things. Now, if anyone ever built a build system before? You probably felt like this then, right? You get everything going, and then the entire world falls down on you. So most of these things, we actually built the naive system. I think about 2 years ago, I gave a talk about this warehouse. And it was built with the naive system. So there's a lot of DNS caching in the microservices, which is a good call out to say that microservices are not a silver bullet because nothing is. You need to have certain things in between. The big separation here is we took this problem, we solved it again. The original system had something called Carpenter D, which is the thing that actually goes out and does Webpack and schedules all these builds. We separated out the build component into a worker system. So underneath the covers now, what happens is you npm publish, right? Because that's a really easy way to get your build asset out there. Say, look, it's going to make a tarball for me. It's going to send that somewhere. A reverse proxy receives that. And simultaneously, it sends it to any registry. So it's not a registry, right? You put it in front of a private registry. You put it in front of Artifactory. And then it just writes, because you're releasing the version. And then simultaneously with that, it goes out and says, hey, can you make a build for me of that? That's going to start your npm install, upload the tarball, kick off the Webpacks. Specifically, what that does is it runs npm install. And when that's done, it goes out and it says, hey, NSQ, I'd like to build these systems. And the worker picks it up from some set of Kubernetes pods. And it says, OK, great, that's fine. We've got 50 pods around. They're listening for messages. They're going to go out. And every time, they're going to store those files. And it's this reversed arrow here up there in the top right, the one, see, both things are pointing at our queue. That's the important thing. You want to pull and not push. So let's talk a little bit about the future, right? You'll notice that in that past diagram, npm install still happens in that traditional way, meaning that if you get a lot of concurrent requests to, say, build the initial version, you're going to hit the same problem. And it really boils down to the idea of what is scale, right? You hear this word a lot. What does it mean? For build systems, and I think for most systems, it means elasticity, which means that you can handle things that are very spiky. In the case of a build system, that means coming out and everyone gets in at 9 a.m. on Monday, and they want to release their build. And so even though your week-long workload is maybe you do 500 builds, 1,000 builds, all of them happen on Monday morning, almost all of them. We have that was weird. Sorry about that. So all of them happen on Monday morning. You have this giant spike of work. And the challenge with that is that it doesn't matter how much in between you put in your system if you don't have enough workers. So you've got to go out and say, look, how do I give the system a signal to scale up and scale down? Right now, we're using a Kubernetes plugin that actually does overall workload on a given node. So if the node threshold or the node CPU goes above a certain point, it says, OK, well, I need more nodes, so I'll go schedule those out. Another really interesting candidate for this that we're exploring is Lambda and serverless solutions. The challenges with Lambda for build systems out there is that they have a pretty low set of thresholds. I think it's 500 megabytes for disk and a certain amount of time that they can run. So if your npm install tarballs are big because node modules is heavier than a dark star, you're going to have problems there. But we are exploring it. There's some interesting places there. And that, right at time, is it. Lastly, if you're interested in any of these things, you can find them on the internet. You can run them as well. They're all out there. They're all open source. Thanks to everybody who contributed to this. And that's it.